is wonderful, it helps us, but only if we know how to use it. And sometimes it's easy to make the problems more complicated than they need to be by trying to find a formula for every calculation we're doing. Okay, so let's just kind of talk about when do I have to go to my formula sheet and when do I not. So let's look at this problem. So let's say I'm going to roll a 10-sided die. So here are my possible outcomes that I'm looking at, A, B, and C. A is an even number. So if I'm rolling a 10-sided die, what would be the even numbers? Yeah, let's assume it is numbered 1 through 10. So does everybody agree those would be my outcomes for A, all the even numbers? All right, B is a number less than 6. So what would be my numbers less than 6?
1, 2, 3, 5.
A number bigger than 8. 9 and 10. Okay. So if I'm looking at this, I have all my outcomes. Let's see if we can do these probabilities. So probability of B. We know that in general, probability is just the number of outcomes in the set divided by your total. How many total outcomes are there if we roll a 10-sided die?
10.
There are 10 options. All right, how many of those are in set B? 5 out of 10 or 0.5. All right, so I didn't have to go to a formula there. I just calculated a straightforward probability.
If we had something like that and reduced it to 1/2.
That's fine. Yep. Fraction in lowest terms or decimal. Good. All right, B, the probability of C. All right, there are 2 outcomes in C. We're looking at every possible outcome, so 2 out of 10 or 0.2, not 0.5. Okay, C, the probability of A and B. So I know we still have 10 outcomes. A and B, how many numbers show up in both A and B? And is looking for the overlap. So basically saying they have the same number. So they both have a 2. They both have a 4. So the set A and B would just be 2 and 4. And is looking for the overlap. Remember, like if I drew a diagram. Here's set A, here's set B. Which numbers show up in both of them? What's the overlap? So there are only 2 numbers out of the 10 total, so we get 0.2. D, A or C. So this is counting every number that's either in A or in C. Or means what? Adding. Okay, you might be able to just do this by looking at your sets. If you wanted, we could look at our formula sheet. Let's kind of talk about it. So when we're looking at ORs, we have 2 options. We have the addition rule for disjoint events. What does disjoint mean? Mutually exclusive. They have nothing in common. If I look at A and C, do they have anything in common? What do they? They both have a 10. So they are not mutually exclusive because if I drew them out, there's an overlap. They have something in common. So I need to go to my general addition rule. So it tells me the probability of A or C is probability of A plus probability of C minus probability of A and C. All right, how many numbers are in set A? 5 out of the 10. Plus, how many numbers are in set C? But what have I done? I have double counted the number 10. So I have to subtract that 1 off because he got counted twice. So we should get points. Does that make sense? All right. E. When we get into conditional probabilities, your condition is the denominator. So my condition is being in set A. How many numbers are in set A? 5. The numerator is kind of like an and. How many numbers are in both C and A? Just 1. Only the 10 shows up in both of those sets. So we get 1/5 or 0.2. Let's do another condition. B given C. So your given is your denominator. So my denominator is set C. How many numbers are in set C? 2. The top is looking for the overlap, B and C. How many numbers show up in both set B and set C? 0. If I know it's in C, it does not show up in B, so that one is 0. That's impossible. G. Are A and B mutually exclusive? What does mutually exclusive mean? Yeah, nothing in common. So if I look at A and B, we have already said they both have 4s and 2s. They share something. They overlap. So they are not mutually exclusive. All right, last question. Are they independent? So, if you're struggling with what independent means, if you look on your formula sheet, we have in the back a multiplication rule for independent events and a general multiplication rule. And so the difference, if they are independent, it says that the probability of E and F is just the probability of E times the probability of F. If they are not independent, it says the probability of both things happening is the probability of E times the probability of F given E. So what independence means is that the probability of F is the same as the probability of F given E. If they're independent, these probabilities have to be the same. So if A and C are independent, the conditional probability has to be the same as the original. So if I look, we found the probability of C given A. If they're independent, that would have to be the same as the probability of regular C. Are those numbers the same? Yes, so they are independent.
What was the one where it was like it has to equal 0?
Mutually exclusive means the and has to be 0 because they can't both happen. Take a look at another problem. So sometimes I think when I give you a problem in words, it's hard to read this and figure out what you have at the end. So let's kind of practice that skill. Looking at this and figuring out what on earth it's telling us. So in order to be accepted into a graduate program, applicants must get a qualifying score on the GRE and have an acceptable GPA. From past experience, the admissions counselor knows that the probability of having an acceptable GPA is 0.83. So the probability they get the GPA is 0.83. Of those with the GPA, the probability of getting the score is 0.64. So what they're saying is we already know they have the GPA. So if they have the GPA, the probability they get their score. So the probability they have the score given they already met the GPA requirement is 0.64. I'm trying to find the probability they are accepted. And it said to get accepted, they have to have the GRE score and the GPA. So to get accepted, they need the score and the GPA. That's what I'm trying to find. All right, when I think about and tells me I'm going to be doing what? Multiplying. So we might just be able to recognize, okay, and means I need to multiply, so multiply those two things. If you look on your formula sheet, we have a general multiplication rule. It says the probability of E and F is the probability of E times the probability of F given E. So I knew I needed one of the two and formulas. I looked, I had a conditional probability in here, so that told me I probably need the one with the conditional probability. So all we have to do in this scenario is multiply. What?
How do you have an 8-4?
I don't know. Thank you. I think I looked at a combination of my two numbers. That should be an 8-3, shouldn't it?
Oh, okay. I was like, wait, where did we get that?
No, just, and I typed 0.84 on my calculator too. Okay. How about 0.5312? Thank you. So sometimes when you have a problem that is a whole paragraph, it looks really, really confusing. But the actual calculation, if I realize, oh, I'm looking for an and means multiply, I'm just multiplying those probabilities together. All right. Another one that I know we've kind of had some trouble with. Something along these lines. So in a game, you draw cards from a deck containing 3 black cards and 5 red cards. So how many cards are in my deck? We have 8 total cards. Okay. To win another turn, you must get 3 black cards in a row. To win the game, you have to get 5 red cards in a row. So first, I want the probability of winning another turn. How do we win a turn? 3 black cards. So we have to get a black and another black and another black. And means what? Multiply. So we're going to be multiplying 3 things. So the first time I pick a card, how many black cards are in there? 3 out of how many total?
8.
All right, I have taken out a black card. How many black cards are left?
2.
Out of how many total?
7.
Okay, I've taken out another black card. So how many black cards are left?
1.
Out of?
6.
Okay, so if we multiply those. B, I want the probability I win the game. How do you win the game? Yeah, so we need red, and red, and red, and red, and red. And means?
Multiply.
multiply. So we have to do it 5 times because I have to get 5 cards in a row. Okay, the first time I draw, how many reds are there? Out of? Okay, if I've taken out a red, how many reds are there? Out of? Next time. Out of? Next time. And the last one? All right, so if we multiply these. Interesting, we get the same probability. Okay. The third option, not winning anything. These are the only 2 ways you win. So anything else that happens, you lose the game. So what would be the easiest way to figure out the probability you lose? 1 minus both of those. Okay, those are the 2 ways you win. They're complements, so you just take 1 and subtract off the 2 probabilities of winning. There's a 96.42% chance that you don't win anything in this game.
Well, that's
Yeah, would not be a very good game to play. I know we've had a lot of these replacement type questions. You know, we had the one with the tires. I think we had one with drawing like yellow and red flowers out of a bag, those kinds of things. Does this make sense? Yes.
What's the situation if they have to like cube it for like the number?
When it's just independent events. So if I said like I was going to put the card back and then draw it out and look at it and then put it back, you could do that because its probability is the same every time. Or we had one where it was like the probability of being vaccinated was 77%. So if I took 5 random people, they all have the same probability of being vaccinated, so you could just take it to the 5th in that scenario.
Are we gonna have you guys on the quiz?
You could, but since I'm not reviewing it, it probably won't be on this quiz. All right, last one. We have done a lot with reading from the table. So let's try one of these. So we asked middle school students if they liked their class offerings. So we have broken up by grade and if they answered yes or no. So the probability of yes, given they are in 5th grade. When I'm looking at this, what goes on my denominator? The 5th grade. So when I'm looking at my 5th graders, how many total are there? 54. So my denominator is 54. Out of those 5th graders, and those 5th graders only, I want the ones that said yes. So 20 out of 54. Get 0.370. B, the probability of no. Did I give you a condition here? So that means it's out of everybody. So we need to add up everyone in our table. We have 228. And then what goes on the top? Everybody who said no. C, the probability of being in 8th grade and saying yes. Did I give you a condition? No, if there's no condition, it's out of everybody. So I want only those people who were in 8th grade and said yes, they liked it. So 8th grade and yes, there were 41 people. Get 0.179. Last one. 8th grade given yes. So there's a given. So my denominator is all of the yeses. So if you add them up, 107, is that right?
Mm-hmm.
So my denominator is 107. So I am only looking at these yes people. And I want the ones that were in 8th grade. So 8th grade and yes was 41. And get 0.3832. Do you have any other questions? So if you would, put everything